Hey everyone, welcome back to 3D Now. So you may have seen my Ultimate Beginner's Guide to 3D Printing that I made a while back, and that video had a ton of interest. So I wanted to make an updated version for 2020, and a lot has changed. So in this video is going to be a lot of up-to-date information about 3D printing and an awesome beginner's guide into the awesome world of 3D printing. So what is 3D printing? So it is defined as, quote, the action or process of making a physical object from a three-dimensional digital model, typically by laying down many thin layers of material in succession. So on the left, you can see is a 3D model of what we call a 3D benchy. So it's a boat. We call it the benchy. And on the right is me 3D printing out that model into the physical world. So I have my model on my computer, the 3D model of that benchy, and then I'm going to lay down thin layers of plastic in succession to eventually build up that 3D model into the physical world, which I'll get into in a little bit. So as you can see here, the possibilities are literally endless. You can print so many awesome things, and it has so many awesome uses in life, as you will see throughout this presentation. So first off, let me break 3D printing up into two main groups here. There's consumer 3D printing and there's industrial 3D printing. And in this video, I'm going to be mostly focusing on the consumer 3D printing because that's what most of us here are looking to learn about. So on the left there, you can see a consumer 3D printer. It's called the Creality Ender 3, and it's one of the most popular consumer 3D printers because it's super cheap and is a great printer overall. On the right there, you can see an industrial 3D printer that is called a Stratasys F170, and that is a huge machine. It's the size of a refrigerator pretty much, and that is super expensive, meant for industrial applications, commercial grade 3D printing. They make really great objects, but those are just way outside of our consumer range for right now. So let's get started. There are many types of 3D printing. And as you can see, there are many ways to cure layers of material, as that is what 3D printing is defined as. So the first and most popular is called FDM or FFF 3D printing. The FDM stands for Fused Deposition Modeling, and the FFF is just another term for the same process, also known as Fused Filament Fabrication, but they're mostly the same thing. And this 3D printing consists of heated thermoplastics. So this is the most common type. As you may have seen, these printers lay down these spools of plastic layer by layer. They're very common, and most of this presentation is going to be on FDM 3D printing. There's also another type of 3D printing called SLA 3D printing or stereolithography, and these 3D prints are very, very detailed, and that's because they use a laser to cure resin in a bath. So it's a big tub of resin, and a laser shines on that, curing the resin layer by layer as the bed moves up and up. Also, there's a version called DLP, called Digital Light Processing, and that's another resin curing system, but it's very, very fast because it uses an LED projector to project light onto the resin to cure it. Also, there's one called MSLA, called masked stereolithography, which is very, very cheap because it uses an LCD screen to cure resin as well. So light shines up through the masked LCD screen to cure the layers of resin. So these are the four most used 3D printing types in the consumer 3D printing industry, but there are many, many more types of 3D printing that move into the industrial 3D printing section, so we won't get into those in this presentation. So let's get started with learning about FDM or FFF 3D printing. So as you learned before, it is the most common type of 3D printing. Material is pushed and melted through a very small nozzle and is raised layer by layer, creating our 3D model. And it is printed onto a surface using gravity and pressure. So on the right there, you can see a little diagram of FDM 3D printing. That nozzle there is pushing out this thin layer of material. You can see there it's stacked one on top of another. So it's laying on top of each other the next layer. So this material is being laid down and melted, and it fuses to the layer beneath it. And this creates a buildup of layers of material, of plastic, and that creates our 3D model. We'll get into that a little bit more later in this presentation. Also, we have SLA 3D printing. And these are very high detailed prints because they use a laser to selectively shine on resin, and that cures it layer by layer. And SLA actually prints upside down as the object is pulled from the resin. So in the diagram on the right there, you can see the bed is actually pulling the object up and it's being printed upside down. And that's because the laser is below the bed of resin and it's shining that laser all around the bath, curing one layer, and the bed moves up, and then it cures the next layer of resin, and then it moves up again until the part comes out of the resin. It's really, really cool. So the next 3D printing type is called DLP, which has very, very fast print times as the entire layer is cured at a time. Also, it uses a high power projector that shines into late cured resin to cure each layer. Just like SLA 3D printing, it is printed upside down as the object is pulled from the resin. So in this picture here, you can see that instead of a laser being shined into the bath of resin, there is a projector that shines up and cures an entire layer at a time, which is very, very fast. But it's also not as detailed as SLA 3D printing. So MSLA 3D printing. This is a very low cost option for resin 3D printing. It uses an LCD screen with an LED backlight that cures the resin. Also, it's printed upside down as the object is pulled from the resin, just like the other two resin 3D printing types. So on this image on the right hand side, you can see this grid of LEDs that shines up through an LCD screen. So the LED backlight shines through the LCD screen, which masks out certain parts so the light can go through one part and the light cannot come through another part of the LCD screen, and that selectively shows the layer that the printer wants to cure. So the 3D printing process, this is the biggest thing to learn and know with 3D printing. This is how you start with a 3D CAD model and go through the whole process to have your 3D model in physical life in your hand. So let's get started with learning the 3D printing process and how to 3D print an object from scratch. So of course, the first thing you need is your 3D CAD models. So you need the actual thing you want to print. So there are two ways to find 3D models. The first one, which is also the easiest, is to just find models online. And there are many great websites that have 3D printable models that you can just download for free. There are websites like Thingiverse, My Mini Factory, Colts, and GrabCAD that host a bunch of models that you can download and 3D print, which is super cool. You can see on the picture in the bottom right hand side that is Thingiverse, and you can see all of these cool objects that are on the popular page. So these are the most downloaded objects on the website, and there are some really fun things that you can print out. The other way to find 3D models is to make them yourself. So you can create your own CAD models or computer-aided design, and there are many CAD programs that you can use. There's Fusion 360, there's Onshape, SolidWorks, Inventor, Tinkercad, and many, many more. I also made a tutorial on how to get started with Fusion 360, which I will link in the iCard above if you want to learn how to create your own CAD models for 3D printing. So you can see in the picture on the bottom right, that is Fusion 360, and that is just a default object that someone made of a box cutter, which is pretty cool. So you can actually create from measurements if you want, or from scratch. In the program, you can create your own 3D model, which then you can print and have it in physical life, which is super, super cool. So the next step is the STL files. So you're going to export your 3D model if you use a CAD software, or if you find them online, you can just download them as an STL file. And there's also another file type called OBJ that works the same as STL files. So these files are made of many, many small triangles. And these are the 3D model that is easily read by the slicing software, which I will get to in a few slides. And you can see here on the right is an image of what an STL file would look like. You can see that little red circle around the outside, that's what your CAD model would be. But the STL is that inner portion, which is all made of triangles. And that is the object that we're going to be able to 3D print. So you can see the more triangles you have in your STL file, the more detailed it would be. So when you're going to export your 3D model as an STL file, you want to have as many triangles as you're comfortable with. And of course, that will bump up the file size as well. But most 3D prints are pretty small, so you won't be able to see these triangles as much as you would think. Also, you can see this image of a controller, which is made of many, many small triangles. But if you look at it from a wider view, you can see that it looks pretty much like a controller. When you 3D print it, it'll look very, very smooth. So slicing software. This is the software that we're going to use to slice our 3D models. So there are many slicers on the market. As you can see, there's Ultimaker Cura, Simplify 3D, Slicer, Repetier Host, Prusa Slicer, Formlabs Preform, and many, many, many more. Some slicers work with many types of 3D printers, while others are specifically made for certain printers. Like Formlabs Preform is made specifically for Formlabs 3D printers. Just like Prusa slicers made specifically to work well with Prusa 3D printers. But some like Cura and Simplify 3D are made for many, many types of 3D printers, and you can use them on most 3D printers. So what is slicing? So slicing a 3D model, it slices a 3D model into the layers to be 3D printed. So like we said in the beginning, 3D printing is laying down these thin layers of material in succession. So our slicing software actually creates those slices of our model. This is also the place where we're going to be able to edit the settings and properties of our 3D model. So you can edit the print speed, how fast it's going to print, the infill, which is the density of material inside our 3D model, the layer height, which is the actual height of each individual layer. We can change the 3D model size and its orientation on the 3D printer. We can edit the temperature of the nozzle and the bed, and so many more settings. There are so many settings that you can print with to make your 3D model come out just like you want it to. And when we're finished slicing our 3D model, it's going to create a toolpath for our 3D printer, which I will get to in a few slides. But first, let's go over some slicing fundamentals. So I'm not going to get really in depth. I also made a video on slicing with Cura, which I will link above. You can click that if you want to learn about slicing a little bit more in depth. But very basically, there are three major things that you should know when slicing a 3D model. So you want to think about the model's orientation when you're slicing it. On the left-hand side, these traffic cones, the cone on the right is standing upright. So it's going to print those layers one on top of each other to print up that cone. But the left traffic cone, you can see, is printed on its side, which is much harder. And that's going to need supports, which is that little lattice structure you can see underneath the cone. Because printers, or FDM printers, cannot print in midair. As you can see in the middle image, it's called bridging. The printer cannot just print plastic in midair, so it'll just flow everywhere and go everywhere. It has to actually print on top of something, right? So if we printed this cone on the side, we need to add this support that is printed under the overhang area of the cone, which then extends the print time. It may leave some residue on the print, and it's basically just not the best way to 3D print. You want to print your object in an orientation that makes sense and print fast. Also, the image below that you can see is putting load on a 3D print. So you have to remember your 3D printer is printing layer by layer up and up and up and up. So if you print that standing straight up, the layers are going to be horizontal to the ground or to the print bed, right? So if you push a load, it's going to crack on those layer lines, right? So you have to think about that when slicing. So it will be much better if you turn that L on its side and print the layers on another axis. So then when you press on the object on that same point, if you put a load on that same point, as you can see in the green circled image, the layer lines are not in the direction, so it won't crack or split apart on those layer lines. So as I mentioned before, there's bridging and overhangs. You don't want to print in midair because we can't do that, right? So we need to have something underneath our model to be able to print. So the first layer, you're going to print on the bed, which is fine. When you print up, you're printing layer on top of layer on top of layer. So that's fine. But you can't just print in midair because you get all this stringing here. So you have to be aware of your model orientation. But sometimes models need to have some overhangs because the model just has overhangs that you can't really avoid. So you have to add support underneath those areas. So that's a setting in the slicer that you just click, and it's going to add this support, this lattice structure, like you see on the cone on the left, that helps support the 3D printer or the plastic being laid down as it goes over to the next area that's being 3D printed. So you won't get this stringing that comes with bridging and overhangs. Also, there is something called infill, which I touched on a little bit before, and that is the density of material in your 3D models. On the leftmost block, it is pretty open with that grid, and then the middle block a little bit more dense, and the block all the way on the right is 100% infill. So normally when 3D printing, you don't need your part to be solid, right? So you can do 15% infill, 20%, and that'd be plenty strong for most applications. Also, there's layer height, which is the actual height of each individual layer that the 3D printer lays down. So you can see on the image on the right hand bottom side of the slide is a pretty thin layer that's 0.1 millimeter thick. The middle one is 0.2 millimeters thick. One on the far right is 0.3 millimeter thick layers. So there are certain advantages and disadvantages of different layer heights. Like the thinner the layer height is, the more detail you would get, but also it's going to take a lot longer to print. Also, if the layer is thick, it'll print a lot faster because it's actually laying on bigger layers at a time, but also you're not going to have that same print quality. So either can print slower with higher detail or print faster with lower detail. So you have to pick and choose what height you want your layers to be. Okay, so now we're going to move on to G-code, which is the toolpath of our 3D printer. So when we finish slicing in our slicing software, we're going to export or download that file that we made as a G-code file. So most consumer 3D printers use G-code as the instructions to print. So G-code is made up of a bunch of commands. So each line has a command that tells the printer exactly what to do. And the commands tell the printer where to move to print a line. So on the bottom right, there is a list of a few commands, and in the middle image you can see a few lines of G-code. So your file is going to be made up of all these lines of commands that tells the printer, okay, go to this point, go to this point, go to this point, heat the nozzle to this temperature, print this fast, things like that. G-code are the actual instructions that the printer is going to use to 3D print your model in the real world. So now it's time to talk about 3D printers themselves. So we're going to have to load our G-code file onto the 3D printer. And we can do that over the internet, through an SD card, or through a USB cable. And there are many types of motion systems for FDM/FFF 3D printers. And they all lay down melted plastic layer by layer. But there are different motion systems that printers use to lay down that material. And by far the most popular is the Cartesian system, which is on the far left, and it uses the Cartesian coordinate plane. So you might remember in school, if you plot a point, it's XY, or you can go XYZ to be in 3D space, right? So it's the same thing. We use an X-axis, there's a Y-axis, and a Z-axis that moves the print head in those positions, right? So it moves X and then Y and then Z. It's a Cartesian motion system. There's also another one called delta, which is the second one over, and that is pretty cool. It uses 3 towers that each individually move up and down, that moves the head around and prints out an object. Deltas are pretty cool because they make very detailed prints, but also the print area is not very large unless you get a very, very big delta printer. Also, there's a motion system called polar, which uses the polar coordinate system as compared to the Cartesian coordinate system. Now, the polar coordinate system uses a radius and an angle as compared to points, but it's still very similar because it moves the nozzle forward and backwards, up and down, but then the bow plate actually spins around in a circle, which is pretty cool. Also, there's one called SCARA, which uses an arm that has 2 pivot points that can move the nozzle around and print on the bed, which is pretty cool as well. But by far, the Cartesian and delta are the most popular for consumer 3D printing. The polar and SCARA are not used very much. They're pretty much novelty motion systems for now, but I thought it would be cool just to add them to this presentation so you have some idea of what kind of motion systems are out there for FDM 3D printers. So now we're going to actually have to 3D print our model in real life. So there are many types of materials that we can print out. So for filament 3D printers, the FDM/FFF printers, there are many types of materials. But some of the most popular and most common ones are PLA, called polylactic acid, there's ABS, there's nylon, ASA, there's TPU, which is a flexible material, there's HIPS, there's PETG, there's wood, metal, carbon fiber composites, which may have PLA or ABS as the base or nylon as the base and has some wood particles or metal flakes in there or carbon fiber flakes. That makes a really cool 3D print. And there are also many more materials that filament 3D printers can use as well. So moving on to the resin 3D printers like SLA, DLP, MSLA. So these printers are a little bit more complex as different resins cure at different wavelengths. So all the resin 3D printers cure the resin with light or with UV light. So these resins are photopolymers. So actually some resin printers have to use different resins because different lights cure different resins at different wavelengths. Some SLA 3D printers use different resins as some DLP 3D printers. So you have to be more careful with picking out which resin to use for resin printers. But generally, there are many types of resins as well. Some are flexible, some are very tough, some are very clear, some are matte, and some are dental safe. So some dentists or medical industries 3D print parts for some aspect of their jobs. So here's a list of some 3D printer components, and I just picked 3 major areas of a FDM 3D printer just to share with you guys. So there are nozzles, which is very important. This is where the plastic is squeezed out and laid down layer by layer. There are many types of nozzles that come in many different materials. The most common is brass, but you can also get some in hardened steel, even ruby-tipped nozzles, which are pretty cool. So if you're printing very abrasive materials, like say carbon fiber infused PLA, the carbon fiber is going to wear down your nozzle very fast. So you might need a hardened steel nozzle or even a ruby-tipped nozzle so that the material won't wear away your nozzle as fast as it would with, say, a brass nozzle. Also, there are different size nozzles, like 0.2 millimeter, 0.4 millimeter, which is the most standard, and there's also 0.8 and many more sizes. And like I said before, with the different layer heights, the smaller your nozzle size, the more detail you can get in the print, but it's also going to take more time. And the bigger your nozzle is, it's going to be less detailed, but it's going to print a lot faster. So there is a trade-off there. In addition, there are a lot of bed surfaces as well to print on. There's glass beds, there are textured surfaces which you can print on as well. There are beds covered in PEI, which is a material that sticks very well to 3D printing materials and keeps your print stuck to the bed while it's printing. There are also some flexible beds where you can just flex the bed itself and your print will just pop off, which is pretty cool. Also, there are magnetic beds which stick to your printer with magnets, and you can pop it off with the magnets and then flex the bed maybe to pop the print off. Also now, most beds are heated as well for printing more materials. So a lot of the materials need to have a heated bed in order to stick to the bed while it's printing. Also, there are two main types of extruder systems. The extruder is what pushes out the plastic. So it has a motor that spins a gear that pushes out the plastic through the nozzle that's heated up and that melts it and then lays it down layer by layer. So there's a direct drive extruder, which is where the motor is close to the hot end. You can see that image down there is a direct drive hot end, where the motor is right above the hot end and nozzle, so it has a very short path to push the material to the hot ends, which is a benefit for, say, printing flexible materials like TPU. Also, there's a system called Bowden, which is where the motor is attached to the frame. So the motor is a heavy part of the hot ends, and it's being placed on the frame of the printer, and there's an actual tube that goes into the hot end. So that means there's less weight on the actual hot end that's actually moving around and printing the object. So with less weight on the hot end that's moving around, you can actually print a little bit faster than you could with a direct drive system. So many of you may have seen multicolor or multi-material 3D prints. We can print multiple colors or materials in a single 3D model. And there are multiple ways to do this. You can do it with a single nozzle or with multiple nozzles. And nowadays, printing multicolor with single nozzles is becoming much more popular, as there are many, many good ways to do it compared to multiple nozzle options. So with a single nozzle, you can use a system called a mosaic palette, which I also made a video about, and I'll link that in the iCard above. And that actually takes in 4 different colors of filaments or 4 different materials and cuts them up and splices them together, heats them up, and fuses them together into one long strand of filament that feeds into your nozzle, which is pretty cool. Also, there's something called a Prusa MMU, which is the Prusa multi-material upgrade, uses up to 5 different filaments and feeds them individually into the hot end itself to be melted and extruded out. There are some more rudimentary options, like a filament swap, which is where, say, halfway through the print, you can actually pause the print and then take out the filament color that's on right now and then insert a new filament color into the printer, and that print will finish with that color, which is not very detailed, so you can't get very detailed color options in your print because you might have like one half one color, one half another color, but it's also pretty cool if you want to perfectly time different layers to be different colors. Also, there is something called filament mixing, which is where a nozzle actually has multiple filament colors being pushed into the nozzle at the same time. It actually mixes all those colors together and extrudes out into a very cool multicolor pattern. In addition, there is a hot end called the diamond hot end, which is one hot end and one nozzle that actually has 3 different areas to put 3 different filaments into the one hot end, which then each color can individually be pushed in or pulled out to be melted and extruded out onto the bed. So moving on to the multiple nozzle systems, there is a chimera, which is 2 nozzles side by side, as you can see in the picture above. And there are 2 different nozzles with 2 different filaments going into each one, which then the printer can print those 2 different materials during the print. In addition, a lot of printers come already pre-built with dual extruders, like the Ultimaker 3, also the BCN 3D Sigma R19. The FlashForge Creator Pro has 2 nozzles as well. So if you want to print with multicolors or multi-materials, there are some 3D printers that already have built in this feature to print multiple colors or materials. So finally, here's another beginner 3D printing video that I made, and this just goes over the setup of a new 3D printer. You definitely should watch this video and goes over some problems and mistakes that a lot of beginners have, and I tell you how to fix those individual problems to get a perfect 3D print your first time. I'll link that in the iCard above and also down below in the video description. So I hope this presentation helped you learn about 3D printing and also get some good info about maybe buying a 3D printer or getting in on the world of additive manufacturing. If you have any more questions or just want to talk about 3D printing, feel free to join my community Discord. You can join at 3dnow.cc/discord, and we have hundreds of members that are there to help you out or just talk about 3D printing. Or we also have contests which you can enter and show off your 3D printing skills. In addition, you can check out my website for my recommended 3D printers for beginners and also very good filament to use with a 3D printer. And you can go to 3dnow.tech to find those. So, thanks for watching everyone. Subscribe for more 3D printing videos like this. Comment down below if you have any questions, comments, or concerns. Like this video if you liked it, and I will see you all in the next video.